Large numbers of tent caterpillars can defoliate trees and ruin crops. After they mature, they spin a cocoon and develop into moths that lay eggs. Suppose that an initial population of 2,000 tent caterpillars doubles every 5 days. A. Write a formula for A sub n that models the number of tent caterpillars after n-1 5-day time periods. A hint: A sub 1 is 2,000, A sub 2 equals 4,000, and A sub 3 equals 8,000. So let's find our change factor. We know that A is equal to 1 plus R, and in this case R is equal to 100%, since we're doubling the population every 5 days. So our A value is actually equal to 2. So we'll write our A sub n formula. A sub n is equal to initial population, which is 2,000, times 2 to the n-1 power, where each value of n represents a 5-day time period. So when I let n be 1, that's 1 5-day time period. Let n be 2, that's 2 5-day time periods, or 10 days later. So here's the answer to A. A sub n equals 2,000 times 2 to the n-1. Is A sub n, part B, is A sub n arithmetic, geometric, or neither? Explain your reasoning. Well, since we have this common ratio of 2, then this would be an example of a geometric sequence. C. Find A sub 6 and interpret the result. So A sub 6 would equal 2,000 times 2 to the n-1, or 6 minus 1 power. So A sub 6 is equal to 2,000 times 2 to the 5th power, which is 64,000. So the interpretation would be after the 6th 5-day period, or 30 days, after 30 days, our caterpillar population, tent caterpillar population, will be at 64,000 caterpillars. Part D, give a graph for A sub n where n equals 1 through 6. So let's go ahead and find our values, plot our points. N equals 1, we're at 2,000. And then recall that as every 5-day period goes by, we're going to double the population. So after the second 5-day period, we're at 4,000 caterpillars. N equals 3, we're at 8,000. N equals 4, we're at 16,000. N equals 5, we're at 32,000. And at n equals 6, 64,000. And we'll go ahead and plot these points. N equals 1, we're at 2,000. 2, we're at 4,000. 3, 8,000. 4, 16,000. 5, 32,000. And at 6, 64,000. So there's our graph for A sub n.